I'm Andy Orem at O'Reilly Media, and we managed to get into our studio today Andrew Bashara, who is a fourth-year medical student and also has a degree from MIT in mechanical engineering, which makes him perfect to work on the project we're going to talk about, which is a glove loaded with sensors to do medical diagnosis. So I hear you've been doing a fair number of interviews about this glove that you have invented.
Yes, so recently this glove kind of picked up. This glove is it's for medical diagnosis. Basically, the idea is the problem with medical technology right now is that a lot of the medical technology is taking physicians away from the patient's bedside and putting them in front of a computer. And our vision is that we'd like to have a paradigm shift where our glove can actually act as a seamless interface for new medical technologies as they become smaller and better and cheaper to be at the fingertips of the physician. So the physician can still build that healing relationship between the physician and the patient without with the ability to have all the technologies that are available now, the imaging technologies, blood diagnostic technologies. And we've initially started with the goal of applying this technology to the physical exam. And that's a great, powerful place to start, because at this point there's very little in quantifying touch in the medical field. So an example for this would be breast lumps, kind of quantifying their size, and kind of initially aiding the physician in allowing them to quantify touch, so maybe they can quantify the size of a lump and then see the change in that size over time, something that they would not be able to feel compared over 2 weeks period, to from that point eventually augmenting what the physician can do at the patient's bedside.
So I suppose that the physician, it also could be a nurse practitioner, I suppose, or even the patient herself could use this to do some diagnosis.
That's a great question, yes. One of our visions is that in the future this actually will be able to do breast exams via the patient's own hand. So they'll be able to do self-breast exams, or a trained professional, maybe not a physician in the developing world somewhere, could do an exam on a patient and quantify that touch in a way that allows for telemedicine, or even with enough data, diagnosis in the future.
So this really has that visceral, that personal connection between the person treating the patient and the patient. And I suppose the data gets zapped right into a computer or into the cloud so that the person doesn't have to take a break to enter it.
Yes, that is correct. We've developed a data protocol system that actually allowed us to move from our first prototype to our second prototype quite quickly, that allows for integration of new sensors very easily, but also allows for one port of communication such that this data can be sent wirelessly. So in the future, there will not need to be a connection to some sort of computer.
And there'll be a built-in battery in the final version, too, I understand.
Yes.
Okay.
As batteries are getting smaller and more powerful, it won't be too much to carry one on the glove.
So tell me about some of the sensors that you have now. I understand that this is something that looks towards the future, but you've already got some neat stuff on there.
Yes. So our first prototype, we started with 3 force sensors and a vibration sensor. And the vibration sensor is piezoelectric, and the touch sensors or pressure sensors are piezoresistive. And I can't remember the range right now, but they're quite sensitive, and we have been able to sense actually pulse with them. And so that was our first prototype. And because of our data protocol system that I mentioned, we were able to move from that prototype, which we created in 4 days with a team of 3 people, and create the second one in just another 5 days at Singularity University. And this was all with less than $1,000. Now the second prototype we've kept those 3 force sensors and the vibration sensor, and added a sound sensor, accelerometer, and a temperature sensor. So a total of 7 sensors. Right now they're running on Arduinos. We have 2 Arduinos, one for the accelerometer and then one for the other sensors. And we're very excited about moving forward for our 3rd prototype at this point.
I can understand how you would use some of these sensors. Temperature, I know how people take temperature, and you mentioned breast examination, but can you tell us, say, what the ultrasound is used for on the glove as compared to, say, in a clinical setting?
That's a great question. So at this point, our 2nd prototype did not integrate an ultrasound sensor because of the limited budget, but ultrasound is a large component of our future vision, and without a doubt will be on future prototypes. And the power of the ultrasound is that ultrasound gives you is used for so many diagnostic applications after you have a kind of worrisome finding on the physical exam. So it's the perfect next step for a glove. The physician has a glove, they're doing the physical exam, and all of a sudden they realize that they need more information about what's going on. Maybe they've noticed a lump on a breast and they want to know whether it's fluid-filled or not. That can have important diagnostic. It can have an effect moving forward on whether or not go to mammogram or not mammogram. Another example is if you hear a heart murmur. Looking at the actual heart is usually the next step. In ultrasound, it's called an echocardiogram. Now, if you had that on the fingertips of the physician, they could do it right there, get a sense, is this a real valve abnormality or not? Abdominal pain, is this a gallbladder stone or not? So many other applications for where ultrasound could be useful. The reproductive system, there's situations in the kidney. So this is quite powerful moving forward. And the great thing also is with integration of various sensors, you could give the physician more information than just one sensor at a time, to the point where if you have collected enough data, you can start to make recommendations for the physician that they might not have thought about because of the integration of maybe sound and touch and with ultrasound. And the possibilities of this are quite immeasurable.
I would ask a bit about the software, although I know you're not the software engineer on this project, but I would imagine you need quite different software to have the glove use things like ultrasound or the accelerometer. And how has this worked in? Is it just on the Arduino?
It's a great question. So our vision, so initially right now everything is on the Arduino. And we have not included the diagnostic software at this point because that requires large quantities of data that we have not collected yet. Now moving forward, so initially the data analysis, deciding which components of the sensor's data is most valuable, that code will be on the electronics of the board. Initially the Arduino, but eventually a hard-coded board. Now, once you decide what pieces of information are most valuable, maybe you're much more interested in the distribution of pressure than the actual values of pressure at every point on the graph that you're looking at. So that information, once it's collected and we've decided what is most important, that it will be sent via our wireless COM port to our cloud where it can be compared to the larger collection of data and be correlated with the patient's records to get an assessment of is this patient at risk for breast cancer? Do they have a family history of breast cancer? So once you can start to correlate it with the patient's data, which you can start to do, you can start to make decisions that are almost on the level of what a physician can do.
I'd like to ask about getting the product to market. I assume you have to make sure it's hardened, especially if you want it used in difficult environments, tropical areas, and stuff like that. So how can you make sure that the sensors will remain working and be protected?
Yes, so it's a great question. Something we've been thinking about more recently for our next prototype. One thing we'd like to do is kind of make sure that we don't have it, as everyone could see, the wires kind of were all over the place for the prototype, for the second prototype. We'd like wires to be integrated fully into the glove, and we found technologies already available that can allow for that, and allow creating kind of shields for our sensors, and choosing our sensors very carefully so that they're robust. At this point, we're thinking mostly about MEMS sensors, and building kind of the shielding for the electronics is going to be quite important, and a lot of the mechanical engineering behind that I'll have to kind of design and think about. We have not, up to this point, thought of a specific way that we would allow the glove to be immersed in water, so at this point we're going to try and avoid that as much as possible, but the robustness of the glove has been on our minds, most of all to make sure that something doesn't change and it's still collecting data but not to its optimal level where it might give incorrect data. So really that is the most important component of making it robust initially, so that there are alarms that go off if something has been changed as far as data collection, where it's still collecting data but not to its optimal level.
And do you have a timetable for the next prototype and the final release?
Yes, so our goal moving forward is to have a high iteration level where we create a quick prototype, get it in the hands of physicians, see their response, see their needs, and then respond accordingly. So we'd like to have an iteration created in 3 to 6 months to get it in the hands of physicians. Now moving forward from there really kind of depends on what the physician says. And a lot of the things we learned at Singularity is with this idea of a lean startup, the idea of being very careful about the decisions that you're making moving forward and not making assumptions about the customer market. Although even in my case, I'm a medical student, I work with physicians a lot. Sometimes they don't even know exactly what they want until they have the glove in their hand and know. So it's this very rapid iteration process that I think will allow us to be successful moving forward. So depending on that milestone, that first iteration milestone and what physicians say, I think it will kind of determine how our timeline moving forward. But I imagine having a complete product in 2.5 to 3 years, where we can really have it on the market and have physicians using it comfortably and being integrated into medical practice.
Is this going to be open hardware, or is it just going to be a product?
Open. So there, at this point, everything we've done has been kind of open hardware with our Arduino system. I think as far as kind of protecting our technology as it grows, because I know a lot of larger companies are trying to find ways of doing more comfortable breast exams and making the setting more comfortable for patients coming in. I think we'll have to be careful about what we create that is intellectual property that we need to protect, and what we can create that's open source. So I think we'd be very comfortable allowing the hardware, as far as the sensors and how we kind of decide which data is most important bringing in, to be open source. But I think the diagnostic analysis would likely, and that kind of the data itself would have to be proprietary.
So you're working with this with two other people. And how do the three of you meet and decide to do this project?
Yeah, so I had a great experience this summer. I went to Singularity University as just completing my third year of med school. We start to have some elective time. So I went to Singularity University, which I like to summarize as technology camp, but it's far more than that. I learned really how to be an entrepreneur over there during these 10 weeks. And the idea is the first few weeks, we learn about exponential technology. And exponential, the growth of technology, how everything is becoming smaller and cheaper and better to levels that we have never even imagined. You look and I'm sure everyone in the audience understands this, looking 10 years ago, we would never imagine the types of technology that we have now. So we run across many fields: robotics, artificial intelligence, nanotechnology, medicine and neuroscience, forecasting, which is very important. Where are these technologies going to go? Areas such as policy as well, and how policy affects the growth of these technologies, and how these technologies actually affect policy as well. So, and computing and network science as well. So we took these classes for quite some time, and all along you start to get to know the other 80 students from 36 countries around the world, and you start to realize that everyone has their own skill. So there were 4 doctors out of the 80, and as well as a few med students. There were many engineers, many PhDs in various fields, often technology, but not always. People that have worked at the United Nations. So really quite an extensive group of people, and we were kind of told to create teams on our own in various areas that we were interested in working. So I knew I wanted to work on the global health track, and for each of these challenges, there are many challenges: global health, education, poverty, energy. We're kind of given the task of positively affecting 1 billion people in 10 years. So first of all, they teach us that these tools are available to us, and any person can use these exponential technologies. And then they really give us the confidence and the belief that we can actually affect that many people with these technologies by fully kind of integrating them into the way we think. So as we kind of create these teams, we actually started with a team of 6, and then people slowly left for various reasons, that we got down to a team of 3. And Francisca is from Indonesia. She's our computer scientist, and she just completed her degree in computer science. And Ellie Shai is a PhD student from Israel who studied electrical engineering in undergrad and is now studying bioengineering. So between the 3 of us, we covered many areas of the technical side: mechanical engineering for me, bioengineering, electrical engineering, and computer science. And then we kind of understood the need for this device from my experience of being a 4th-year med student. So the team kind of came together, and we just started running. We knew what we wanted to create. We knew our market. We understood the technology we needed. We had the resources available from Singularity University, and things just went the way we better actually than we could have ever expected.
Well, Singularity University certainly pulled together a tremendous team of people, but they also seem to have, by isolating you, they put you in a different frame of mind, totally different from most of us who go through day to day just making incremental changes to life. And they put you in this frame of mind where big things are possible. That's
right. And it's actually, in a lot of ways, the way the idea was built. Mm-hmm. We would talk quite a lot about the tricorder, and this idea that the tricorder that can diagnose a patient from from far away, from scanning them. And this, in a lot of ways, bothered me after experiencing third year of med school, where we do rotations and take care of our own patients. Because, yes, I can see the power of diagnosis, but the thing that was missing was that human touch. So Singularity really gave me the power of being able to say, okay, what is the absolute best way that we can deliver medical technology, deliver medical care without blocking out technology, but also blocking out the human-human interaction. And because Singularity was able to allow me to not say, okay, we need to go incrementally. Let's just go for the end solution. Mm-hmm. And our team started thinking, okay, if we could do this perfectly, how would we do it? And being able to almost have those mental limitations raised from us, we were able to come up with this idea and actually take the first steps toward it.
That is really quite a story. Are there other people? You're at Harvard Medical School. Are there other people, other students there who are doing tinkering with things like this?
Yes. So a few of my friends are going to business school at this point, interested in kind of how to integrate technology with medicine. And I have one friend who's working on a website to kind of to better medical education in a lot of ways, to kind of share data among med students that kind of can save time, the way that they learn, the way that they study. Not so much in the realm of devices quite as much. A lot of the work is being done more on the software side, but my fellow students are doing quite amazing things. I know of one student who is creating a device that makes sure that patients take their medication at the right time and can kind of help them track that and help them remind them of that and kind of understand their context a little bit better. But I must say, I haven't experienced quite the level that I experienced at Singularity up to this point in med school, because I think I think medicine sometimes has to be focused on making very incremental changes, because if you make too big of a jump and you're wrong in some way, you could hurt a patient. So it's very important to be careful how you make changes, especially for treatment. And we're fortunate that we could make that jump within diagnosis, and it can be kind of tested every step of the way without hurting a patient, because initially our goal is to aid the physician and then in the future to kind of augment what they can do. We kind of avoid making those big jumps, but I can see why medicine takes that very incremental way of integrating technology into what they're doing.
But you and your fellow students are certainly at the future point of medicine. This is what the future is going to look like, I think.
That's what we hope so.
Is there anything else you'd like to say before we wrap up the interview?
I'm just so happy and so honored to be here at O'Reilly, and I just have had a great time talking about this, and I hope everyone looks forward to seeing the Med Sensation glove coming out in a few years.
Wonderful. Thank you.
Thank you so much.